autoregressive LLMs really suck. They don't really produce factual, consistent answer. They hallucinate or they confabulate. They can't take into account recent information. They train on information that is 2 years old or so, or whatever snapshot of the crawl is used. They're not really, it's not really possible to make them behave properly other than through this RLHF, which is really perfect. And you can always jailbreak them by changing the prompt and sort of asking them to kind of act as if they were toxic. They don't reason. They don't really plan. They can't do math unless you augment them with tools, which you can, of course. And perhaps Stephen Wolfram will talk about this. And you need to, there's a lot of work on sort of getting them to use tools such as search engine calculators, database queries, etc. Right now, it's a bit of a hack the way this is done. And the thing is, we are really easily fooled by their fluency into thinking that they're intelligent, but their intelligence is very limited and really nothing like human intelligence. In particular, they really don't know how the world works. They have no connection with the physical reality. There's another reason why they suck, and it's basically by construction, which is that a system that produces one token after the other autoregressively is a divergent process. It's a diffusion process with an exponential divergence. If there is a probability at any token that is produced that the token takes you out of the set of correct answers, those probabilities accumulate. And the probability that a string of tokens of length n is correct is 1 minus this probability of error to the power n. So the probability of correctness decreases exponentially with the length of the sequence that is produced. This is not fixable without major redesign. It's really an essential flaw of autoregressive prediction. A while ago, with a colleague, Jacob Browning, we wrote a paper that essentially points out to the limit. It's not a technical paper, it's a philosophy paper, actually in a philosophy magazine called Noema. And it talks about the fact that most of human knowledge is non-linguistic. Everything that we learn before the age of 1, everything that any animal learns has nothing to do with language. And it's an enormous amount of background knowledge about the world that we learn in the first few months of life and that animals know. None of this is linguistic at all. And LLMs don't have access to any of this kind of knowledge. And so the thesis in that paper is that we're not going to be able to reach human-level AI unless we have systems that have sort of direct sensor information in the form of vision, for example. Some way of understanding how the world works. Other papers that have appeared either from the cognitive science, in fact, that paper is from MIT, or from the classical AI kind of subfield, point to the fact that LLMs really cannot plan. They don't have the ability to think, really, or reason in a way that we understand this from humans, and very limited abilities to plan, at least compared to other systems that are specifically built for planning. So I think there is 3 challenges in the future for AI and machine learning research, and I've been showing these slides for several years now, and I haven't changed it because of LLMs. The first one is learning representations and predictive models of the world, where the world can include other people that the system is talking to. And the solution to this is self-supervised learning. We've known this for a number of years. Learning to reason. So autoregressive LLMs are very much like what Daniel Kahneman calls System 1, which basically corresponds to subconscious tasks in humans, tasks that you accomplish without real planning or reasoning, that you sort of accomplish more or less reactively without thinking too much. System 2 is the type of action that you take by deliberate reasoning, using your, the power of your prefrontal cortex, using your ability to predict, and then planning a sequence of actions that will sort of satisfy a particular objective. And LLMs are not capable of this at the moment. I'm going to argue for the fact that reasoning and planning should be viewed as some sort of energy minimization. And then the last thing is learning to plan complex of actions to satisfy a number of objectives. And that will require learning hierarchical representations of action plans, which machine learning systems don't really know how to do at the moment.